Welcome to an inside look at Allied Sintering's precision powder metallurgy process, a recognized green technology. The process starts with carefully chosen raw metals, such as stainless steel, brass, iron, and copper. The metal powders need to be precisely mixed to exact specifications according to your application's performance requirements. These are often combined with lubricants to aid compaction and ejection. Powder particle shape, size, and distribution are carefully controlled to ensure the required strength, wear resistance, and corrosion protection. The blended powder flows from the hopper into the feeder shoe. As it glides over the die cavity, gravity ensures an even fill. The lower punch sets volume, and the shoe retracts, preparing the cavity for compaction. The powder is compacted at room temperature by upper and lower punches, applying forces between 10 and 60 tons per square inch. The vertical stroke densifies the powder into a solid green compact, forming the part's shape. After compaction, the upper punch withdraws, while the lower punch lifts the green compact smoothly from the die. The feeder shoe slides forward, pushing the part onto the takeaway conveyor and aligning over the empty cavity. A new measured charge of powder is gravity-fed into the die, and the system resets for the next automatic cycle of production. The process loops seamlessly, each process step monitored and verified by Statistical Process Control, SPC. Made from hardened steel or carbides, the compaction toolset consists of 4 main components. The rigid die body forming the mold set into special mechanical or hydraulic presses. The upper and lower punches for molding features and/or multiple steps. And, when required, 1 or more core rods for forming internal holes and features. Beyond simple shapes, complex multi-motion tooling in conventional powdered metallurgy allows for intricate, net-shaped parts, eliminating the need for secondary machining. Independently moving punches and core rods create stepped cavities or blind holes. Each section is filled and compacted in a carefully synchronized sequence, ensuring overall density and specifications. After compaction, green compacts move by conveyor into a multi-zone sintering furnace. In its controlled atmosphere, heat transforms mechanical particle bonds into strong metallurgical bonds. The compacts pass through 3 zones: delubrication, preheat, sintering, high heat, and cooling. In the delubrication zone, first stage heat burns off the lubricants, releasing soft vapors as the parts move steadily toward the high heat zone. As the compacts enter the high heat zone, they are heated to temperatures just below the metal's melting point, creating intermolecular bonding. This results in strong metallurgical bonds, locking them into their final shape. The parts cool in a controlled environment in the final zone of the furnace. The compacts solidify into a final density, locking in the precise dimensions achieved during sintering. Inside the furnace, a carefully balanced atmosphere is maintained using nitrogen and hydrogen gases. In the preheat zone, lubricants are burnt away. Sensors continually monitor the atmosphere, ensuring a stable environment and uniform results across every component. Powder metallurgy delivers parts with tensile strength ranging from 21 to over 180,000 psi. Its inherent microporosity enables oil impregnation for self-lubrication. Surface treatments can enhance strength, wear resistance, and corrosion protection. PM offers a broad spectrum of material capabilities, including steel, stainless steel, brass, and specialty alloys for the medical, telecom, automotive, and industrial equipment industries. powder metallurgy also offers a large range of geometric freedom. Radii, flanges, chamfers, and fine surface details can be pressed directly. Core rods create straight, blind, or shaped internal holes, while multi-motion tooling enables complex levels. Fine lettering or logos are also among the variety and detail achievable straight from the press. Allied Sinterings specializes in small and miniature high-precision parts, including custom gears, fine pitch gears, planetary gear drives, spin locks and timing gears, initiators, cams, sprockets, and structural components. Their maximum size is just 1.5 inches in diameter, comparable to a US half dollar. Quite simply, nothing bigger than this. The true advantage lies in net shape, compacts pressed close to final form, to deliver parts with minimal or no machining required. Rigid tooling makes powder metallurgy unmatched in repeatability, producing millions of identical parts. By contrast, metal injection molding has high shrinkage rates, and additive manufacturing is not suited to production quantities. Allied Sinterings is ISO 9001 certified by PRI Quality Systems Registrar and is ISO 13485 compliant. For more information on conventional powder metallurgy, visit our website or contact us today.